Today we will be discussing about optimization problem by using derivative. So, let us see for example that this is the problem. So, that the largest rectangle inscribed in a circle is a square. So, you have a circle which inscribe a rectangle. It can be of the various shapes like this. So, there can be so many rectangles you can which will be inscribed by this circle. Now, the question is that which, if the rectangle among all these rectangles, the rectangle which has the maximum area is going to be a square. Interesting problem. So, now let us take the circle. We can take the circle centered at 0, origin and radius r. Now, you take a rectangle. So, this point, let us say call it as x and y. Then of course, this point will be minus of x and y, this one will be minus of x minus of y, and this one will be x of minus of y. This is what the rectangle. Now, what is going to be the area of the rectangle? So, area is going to be, the length is x, minus of minus x is 2x into the height is 2y. So, 2 which is equal to 4 of x y. Now, this x y point, they are in the circle. So, x y will satisfy. The circle here is x square plus y square is equal to r square for some r positive. So, if we write this, we can write this as x, y is square root of r square minus of x square. This we are looking for x between minus of r to r, because the radius of circle is r. So, now this a is area is a function of x, this is a x. So, now maximum of this function, we apply differential calculus. Therefore, we can, this is definitely a differentiable function as a function of x. So, we can, let us compute a prime, this is equal to 4 times square root of r square minus of x square plus 4, I will take it outside, and x into square 2 square root of r square minus of x square into minus of 2 x. So, this by simplifying, this is going to be, this 2 get cancelled. So, this is r square minus of x square and here minus of x square divided by square root of r square minus of x square. Now, we are interested in finding the maximum value for this function a. Therefore, a prime of x, this is equal to 0, will imply that r square minus of 2x square, this is equal to 0. This will imply that x is equal to r by square root of 2, because x square is equal to r square by 2 and x we are taking in the positive side. So, we will only consider the positive square root, that is r by square root of 2. Now, when x is bigger than r by square root of 2, then a prime, if that means x square, r square minus 2 x square is negative, therefore, a prime is negative. So, a is a decreasing function. So, if x is bigger than r by square root of 2, a is decreasing. Similarly, if x is less than r by square root of 2, then a is increasing, because a prime is going to be positive, a is increasing. So, what do we get? So, at the point x equal to r by square root of 2, on the left hand side it is increasing and on the right hand side it is decreasing. So, this is going to attain the maximum. So, maximum, local maximum rather, at x equal to r by square root of 2. So, when x equal to r by square root of 2, this is what it is going to attain the maximum area among all the rectangles. Now, what happens to y? Now, x square plus y square, this is equal to r square. This will imply that when x equal to r square root of 2, that is where the maximum area occurs, r square by 2 plus y square, this is equal to r square r square. This implies that y square is also equal to r square by 2. Therefore, x is equal to y. That means, a rectangle, this is a square. So, very similarly, there can be many other geometric problem which can be dealt with optimization problem, which can be dealt with the technique from differential calculus. Let us see another example. So, now example 2, suppose we have a parabola and let us take any point. Then we would like to find the closest point on this parabola from this point. That means what? Find the point on the parabola y square is equal to 2x, that is closest to the point 1 4. Okay, 1 4 is not in the parabola and this is the point 1 4. So, now the distance of this, we are looking for the point P. What is that point P? Such that the distance between the point 1 4 and P is the smallest. That means, if we can write it down in terms of a function, what we are looking at is the some local minimum problem. So, how to convert this problem into a problem of calculus? Now, what we want to minimize? We want to minimize the distance. Now, distance, so is for any point, if I take it on the parabola x and y, then the distance is going to be x from the point 1 4 plus y minus 4 square root. that is what is the distance. Now, I want to first express this d as a function of either x or y, then I will take the derivative to apply the differential calculus. So, now in this case suppose y square is equal to 2x. So, let me then just square it, this is equal to x minus of y square plus y minus of 4 square. This is the distance, any distance what I am going to take x y. So, okay. So, this is equal to, I have y square is equal to 2x. Therefore, x is equal to y square by 2. So, this I can write this as y square by 2 minus of 1 square plus y minus of 4 square. Now, this is a function of y. Let me call this as f of y. Now, I am looking for the point x and y for which d is minimum. So, that now we have converted that problem into a function f, which is now a differentiable function, and we are looking for the minimum of that function. Okay. So, now let us apply the differential calculus. So, f prime of y, this is equal to 2 of y square by 2 minus of 1 into 2 y by 2, the derivative of this, plus 2 into y minus of 4. So, this is going to be 2 get cancelled. So, y is y cube minus 2y plus 2y minus 8, which is equal to y cube minus of 8. So, f prime of y, this is equal to 0, will imply y is equal to then y cube minus of 8 y is equal to 2. So, now if y is less than 2, f prime of y is going to be negative, that means it is decreasing, and if y is bigger than 2, so y less than 2 f prime negative, y greater than 2 f prime positive. So, y equal to 2 is going to be local minimum. So, this at y equal to 2, f has local minimum. Right. So, now let us find out what is the point. The point is if y is equal to 2, then y square 4 is equal to 2x. This implies that x is also 2. So, the point is P is 2 2, x equal to 2 and y. So, this point P where it is 2 2, this is going to have the local minimum. This is so, in this sort of problem, first you understand the problem, then formulate it. There will be something which you need to optimize, either you need to maximize or you need to minimize. So, convert your problem into a mathematical problem in terms of the function. Now, essentially what you need to do is apply your differential calculus to find the local maximum or local minimum of that problem. So, then you can solve it. Okay. So, now Uh, Now we will discuss a very important tool to calculate limit, which we can use by, because we are well equipped with differential calculus. Suppose for example, we want to find something like limit 1 logarithm of 1 plus x divided by x, or when x goes to 0. Now, you can see that, I mean, this is limit x goes to 0, ln 1 plus x goes to ln 1, which is 0, and limit x goes to 0 of x is 0. So, this is a 0 by 0 form. Now, we have problem in calculating the limit. So, what is very useful for us is a rule called L'Hopital rule, and it is spelled as this L'Hopital rule. So, let me write, let f and g from a b to r be a differentiable function, be two differentiable, or rather just we can write it as differentiable, where a I can take it a less than b less than or equal to infinity. Let me take some x naught here, and f of x naught is equal to 0, which is equal to g of x naught. In other words, f and g are differentiable function, therefore, in particular they are continuous function. So, this f of x naught is nothing but limit of x goes to x naught of f of x, and this is also equal to limit x goes to x naught of g of x. So, this example f of x equal to ln 1 plus x and g of x equal to x. Both these conditions are satisfied, they are differentiable. Here a, it has to be greater than minus of 1 and b can be infinity. So, because logarithm we are defining for greater than 0. So, now if g prime at x naught is not equal to 0, then I can just put it as limit f of x by g of x, which is equal to f prime at x naught by g prime at x naught. So, g prime of x naught is well defined because it is not equal to 0. So, the ratio we can take. Okay. So, the proof is not very hard, simple. If I write f prime of x naught by g prime of x naught, this is equal to limit f of x minus of f of x naught divided by x minus of x naught divided by g of x minus g of x naught divided by x minus of x naught. This is equal to both the denominator x minus x naught will get cancelled, and f of x naught is equal to g of x naught, this is equal to 0. So, this is nothing but limit x goes to x naught Now, if we apply this theorem for this function here, g f of x is equal to, and g of x this is equal to x, then g prime at x equal to 1. So, g prime at 0 is not equal to 0 and f and g both are differentiable function. So, therefore, limit x goes to 0 f of x by g of x, this is equal to, I can, so f prime at x naught, f prime at 0, this is equal to 1 by 1 plus 0, which is equal to 1. So, this is equal to 1 by 1, which is equal to 1. Okay. So, now, so it is one thing in this L'Hopital rule, it is essential to have that limit x goes to x naught f of x is equal to 0 and so also g of x naught is equal to 0. Otherwise, just blindly we cannot apply L'Hopital rule, that will be entirely wrong. For example, suppose I have limit x goes to 0 2 x square plus 4 divided by 3 x square plus 7. As you can see that this limit is nothing but this limit is 4, this limit is 7, then this is 4 by 7. Now, if I apply L'Hopital to this, then what it is going to happen? Limit x goes to 0, this is equal to 4 x divided by 6 x, this gets cancelled 4 by 6. So, which is not true. Why L'Hopital? Why? Fails? Because limit of g x is 3 x square plus 7, x goes to 0, this is equal to 7, which is not equal to 0. What we want is that g of 0 is equal to 0, f of 0 is equal to 0. So, blindly we cannot apply L'Hopital if it is of the form f by g. We need to ensure that f of x naught is equal to 0 and g of x naught is equal to 0. Now, in order to suppose I have limit x goes to 0 x minus of tan x divided by x minus of sin x. Now, this is f of x is equal to x minus of tan x, g of x will take x minus of sin x. Now, of course, this f is a differentiable function on the open interval minus pi by 2 to pi by 2 and g is a differentiable function everywhere. So, we can consider any small interval around 0 in which this f, both f and g, they are differentiable. So, now, but can we apply L'Hopital here? In order to apply L'Hopital, what the version what we have discussed just now, for that we need to check that g prime of x naught is not equal to 0. Now, if I calculate g prime of x, this is going to be 1 minus of cos x. Now, so g prime at 0, this is equal to 1 minus of 1 equal to 0. So, certainly we cannot apply the L'Hopital the version of the L'Hopital rule what we did just now. So, maybe we may want to have a stronger version of the L'Hopital. So, that is what is the next one. Not necessarily that g prime of x naught is not equal to 0, that may not be needed. So, we can overcome this. So, let f g from a, b to r differentiable such that 1 limit x goes to x naught f of x, this is equal to 0, which is equal to limit x goes to x naught g of x. And then the second condition will g prime of x is not equal to 0 for all x belongs to x naught to x naught plus delta for some delta positive. That means, I have an x naught here, then at least in some right hand side neighborhood of x naught, this is not going, g prime does not vanish anywhere. Okay. Now, if limit x goes to x naught plus f prime of x by g prime of x. As a matter of fact, if g this is equal to L, if this exists and equal to L, then this will also be equal to L. Similarly, this 2 can be replaced by 2 prime, which is g prime of x not equal to 0 for all x belongs to x naught minus delta to x naught, and limit x goes to x naught minus f of f prime of x by g prime of x, this is equal to L, will imply that limit left hand limit of this ratio f of x is equal to L. And if we apply this to double prime, if g prime of x not equal to 0 for all x belongs to x naught minus delta x naught plus delta minus x naught, excepting at possibly at x naught, and limit of f prime of x by g prime of x, x goes to x naught, this exists and equal to L, then this will imply that limit x goes to x naught f of x by g of x, this is also equal to L. So, if the derivative does not vanish on the right hand side nowhere in some interval, then what we can say that if the limit of f prime by g prime exists, right hand derivative, then right hand derivative of f by g is going to be same. Similarly, the left hand derivative, and now if an deleted neighborhood g prime does not vanish, then we can say that if ratio of the derivative limit exists, then this will be same as limit of f by g. So, we will postpone the proof of this theorem. However, first we will discuss some of the example based on this. So, let us get back to our example where f of x, this is equal to x minus of tan x, and g of x, this is equal to x minus of sin x. Now, as you can see, g prime of x equal to 1 minus cos x. So, therefore, on a deleted neighborhood of 0, this is not going to be g prime of x is not equal to 0 for all x belongs to minus delta delta accepting the set 0. Therefore, the limit of x goes to 0 f prime is 1 minus secant square of x divided by 1 minus of cos x. This is equal to limit of x goes to 0. This is cos square x minus of 1 by cos square of x into 1 minus of cos x, which is equal to limit x goes to 0 1 minus of 1 plus cos x divided by cos square of x. This is equal to minus of 2. So, this nicely come out to be minus of 2, and we will see more example by applying L'Hopital rule, and then we will prove L'Hopital rule in full details. Thank you. So,